You said number 9? Number 9, so you said number 9, okay. Go away. Okay. There. All right, guys. So, number 9. All right. It's the one room I can't turn this light off. I love it. So, guys, does anyone remember how to do number 9? Can you guys hear me okay if I whisper? Is that okay? Okay, that's about all I have left. Does anyone remember how to do number 9? And you're like, no. Yes?
Don't you subtract the smaller one from the larger one and then you just keep switching off subtraction?
Yes. And the beautiful idea behind this is, I really want this to be understood. The GCF is the number that both of those are a multiple of. Yes? It's the biggest number that both of those are a multiple of. If they are both multiples of the same number, they are both in the list of multiples of that number. So if I subtract them, the resulting number from the subtraction is still in the list of multiples. So when I subtract, I'm still getting a number that has the same answer. So if I subtract 300 from there, the problem now becomes this. And then what do?
Subtract 240.
Holy shit, subtract again. That's crazy. And now, can you see the answer? I mean, the easiest GCF question is if one number is a multiple of the other one, because then the smaller number is the answer. What's the GCF of 15 and 5? 5, yes? So what's the GCF of 240 and 60? 60. Done. Now I could keep subtracting, but I don't really need to. Do you guys see that? Maybe. I could keep subtracting if you wanted to. Yes? Is that okay? Okay. All right. Welcome. I normally don't need this, and I forgot it was here, but it's so helpful today because I don't have much voice. So, real quick, it just came in. If nobody's asking a question, the floor is yours. You can ask whatever the hell you want to. Let's keep it related to Math 125. That would be really good. Yes?
At the end of class, are you handing us an answer key of
Yes.
the next time?
Yes.
And then also, can you do 10 after?
10?
Yeah.
Okay. I'll get there. I'm sorry. So much stuff. Some of it is even crazy. Isn't that crazy? Okay. I think that's there, everybody. I think. Okay. So number 10. Number 10. Let's take a look at number 10. Okay. So what does that stand for?
Least common multiple.
I love it. So that's the smallest number that they could both multiply up to be. If it was on the bottom, it would be LCD. So, using prime factorization. So even if you have no freaking clue how to get the LCM, you know how to get prime factorization, yes? So how do you prime factor 45? 45, everybody. 15 times 3. I like it. That's a very different way to do it. And that's 5 times 3 times 3. So it's 3 squared times 5. Is that cool?
Yeah.
What about 120?
2 and 60.
2 and 16.
2 and 30.
Is that cool?
Yes.
So it's 2 squared, 2 cubed, times 3 times 5. Now, does anyone remember how to build the LCM from those two pieces?
Is it all of it? Like you give the one side what it doesn't have.
Say again, sir.
You give the one side what it doesn't have.
Yes, sort of. So here, if I'm going to bring the LCM, I take the highest power of each thing I see. If I do GCF using prime factorization, it's the lowest power on each thing I see. So what's the highest power on the 2? Cubed. Highest power of the 3. Squared. Highest power of the 5. And then you just multiply that stuff together. Bless you, bless you. What's up?
I did different factors for 120.
What'd you do?
I don't know how to make them do. I did 12 times 10.
Sure, yeah. Keep going.
Yeah, and I did 3 times 4 and 5 times 2.
So 3 times 4, 5 times 2,
Okay.
right?
Yeah.
4 is 2 times 2, so you get 3 2s, a 3 and a 5. No matter how you start, it's got to end up in the same way. Yeah. Yes.
So for 8, it's if A is an even number and 7 is evenly divided by A, is 14 evenly divided by A? And I wrote no.
Oh, and look, by the way, I'm sorry. 2 6s, 2 7s. I mean, you're talking about number 8.
Oh,
Okay.
I wrote the no because 7 cannot be evenly divided by an even number. Is that true?
No, no, okay.
I don't understand.
So what am I given? What do I know is true? There's 2 things I know is true. 7 goes into A, and A is even. So I know 7 is a factor of A, and I know what else is a factor. If it's even, what's a factor?
2.
2. So I know 7 is a factor of A, and 2 is a factor of A. If those are both true, what must also be a factor of A?
14.
14. So does 14 divide A? Yes. So real quick. What is the rule for 6? How do you tell us something is divisible by 6?
Divisible by 2 and 3.
Because 2 and 3 are relatively prime, and if both rules work. So, how do you tell us something's divisible by 14? If it's divisible by 2 and 7, because 2 and 7 are relatively prime. And I basically said it's divisible by 2 and 7. Does that make sense? Now real quick, if I said it's an even number and it's divisible by 8, does that mean 16 goes into it? Are 2 and 8 relatively prime? Are 2 and 8 relatively prime? Do they share any factors? So they're not relatively prime. Therefore, that's not a rule. Does 8 divide 8?
Yes.
Is 8 even?
Yes.
Does 16 divide 8? Does 16 divide 8? No.
Oh.
Yes?
Okay.
16 does not go into 8 evenly. Okay. But this one, 2 and 7 are relatively prime, so it works. So can somebody tell me what's a rule for figuring out if 15 goes into something? If it's divisible by 5 and 3. If it ends in a 5 or a 0, and the digits add up to a multiple of 3, 15 goes into it. Yes? That's really kind of cool. Could just be me. I don't know. Yes?
Okay, so the reason I read that one wrong is because I read the line wrong, because I read it as 7 is evenly divided by, but it means 7 divides.
Yes, 7 divides
That's
8.
what
Yeah.
I got wrong.
Gotcha. Understood. So like we would say 2 divides 8, and 8 does not divide 2. Yeah. Okay. Yeah. That's the one I can't do. Oh, let's see. 15A. Okay, so guys, I feel like I'm telling us a secret. Guys, on 15A, what can you do first?
You can, simplify, like, divide each by
Cross reduce, yes. Does 4 go into 808? You with me? Do that first. Did you do it already? Are you gonna do it?
Yes.
Do it. Okay. Like, I refuse to do it, okay? 4 goes to 808 how many times? Welcome, Shelby. This is the reality of today. 5 goes into 505. 101 goes into 202. Done. Yeah. So you just keep dividing. Whatever's on the top is being multiplied. Whatever's on the bottom is being divided. So factors can cancel because it's opposite operations. Is that okay? What's up? Wait, now's the time to ask. What's up? So like, yeah, so if you want to look at it a different way, four over 5, 808 is 4 times 202, right? 505 is 5 times 101, yes? So then this 5 cancels, this 4 cancels, and then this reduces. So any common factor on the top and the bottom cancels because the operations are opposite. Yes? Okay, go. Sorry. Oh, man. You guys get to hear all the little things I say to myself as I stand up here. Yes?
It's about my,
What happened?
so this is.
Oh, sure, but I want to see times 10. I want to, that's how the calculator presents it, but when we write it, we write times 10 to the.
Yeah, but can I still read?
Yeah,
Can I, even though it's correct?
yeah, you haven't corrected it yet, so you can still correct it, yeah. Yeah,
Can you do one on ratios? I was still kind of confused on that. Like, I don't think there's any on here.
there's this one sort of. So, look at number 18, everybody. How do you set this thing up? There's a few different ways to do this problem. The most direct way to do it is 4460 miles every 6 months equals, I don't know how many miles. Now, what am I supposed to put on the bottom? I want you guys to, this many miles for this many months equals, I don't know, what has to go on the bottom? Months. Months. I've already established. And I've got years. How do I make this into months? Well, 2 years is how many months?
24.
24. And what's 3/4 of a year? 9 months, yes. So there's 33 months in 2 3/4 years. So what goes here? 33. And then you can either like cross multiply or whatever. You guys kind of with me? So that's ratio. And then when we set them equal to each other, that's a proportion. Good Lord. I am devolving. Hold on. Hello. Okay. I'm gonna have to talk like this, okay, everybody? This seems to work. I hope you're okay with that. Is that better? Yes? Okay. Ooh, got some voice. Hello. Oh, it's gone. Shit. So now you can cross multiply if you want to, yes? Okay. I don't know if that's the kind of problem you're talking about. But there's multiple ways, like the cookie problem. You guys remember the cookie problem? I think it was a cookie problem. There's so many ways. It takes 2 1/3 cups of sugar to make 48 cookies. Yes, remember this problem? You wouldn't believe the number of ways people solved it correctly. You guys kind of went, hey, okay, there it is. I've got to be here, guys. I'm really sorry. This is all that's working. Hello. Okay. Anything else? Yes, Shelby.
Can we do number 16?
16. Oh shit, I wrote all over it. Okay. I sold a car for a profit of $500, which was 12% of the selling price. Okay. What is it you don't know in number 16? Selling price. $500 is 12% of, I don't know. So what are you going to call it? What do you call selling price? X. So 500 is 12% of X. How do I write that part? Yeah, 0.12. What does of mean? Multiplication. And that is as I take myself out, okay? You guys are going to be elementary teachers, and you are going to help me and my colleagues out by teaching these kids what the hell of means. Students have come out of high school recently not knowing what of means. It's driving us a little crazy. So you're going to do it. Of means multiply. How do I solve that equation? Wait, where was it? It was right here. Okay. How do I solve that equation? Divide by 0.12. I'm sorry, this is all that's working at the moment, so divide by 0.12, and whatever the hell that is, okay. That one was, I swear to God, I'm sorry. That one was very direct, because I could say 500 is 12% of, I don't know. It goes right into the equation, yes. Okay. Is that okay? Okay. Yes?
For for 5 on the front page, is that from the textbook? Yeah. I have it.
Oh, yeah. Yes. And as I say that, did I remember to do that one? No, I did, so let's do that one. Oh, I know what it was. It's probably Egyptian and all that kind of stuff. Yes. So, real quick, guys. This is not on the answer key because I just forgot to go back and do it because I didn't have the book with me when I was making the answer key at first. So we can take a quick minute and do this if you want to. I'm going to do it. That's all there's to it. So very quickly, do you guys need to reference the symbols to be able to tell me what this is? You guys remember this? What is this?
32.
32, I love it. Heel bone is 10. You know, that only makes sense. No, it doesn't make any damn sense, but 32, I love it. What about this Roman thing? What is it you look for at first? What do you look for?
The first digit.
And this is my book, so I can write all in it. All right. What do you look for, sorry?
The first digit.
First went to a pair where the first dude is smaller. So what about CM? Is that first dude smaller? Yes. What about XL?
Yes.
Yes. What about IV? Yes. Okay. So what does that mean? What does it mean What does it mean? I got nothing. What does it mean when the first unit is smaller? Beautiful. So see, what am I subtracting? 100 from? So what is that? 900. And then what is XL? Yeah, 50 minus 10. And of course IV, we just know. So I get 944, is that cool? Now, real quick, to be really honest, all of these answers in the back of the book for all the chapter tests. So chapter tests are actually not a bad way to study for something because all the answers are in the back. What's up? I'm sorry.
Should we remember what they mean? Is there gonna be like a key like previous?
I'm gonna give you the exact same stuff I gave you before. I'm gonna give you the Roman numerals, Egyptian hieroglyphics, the Mayan place value stuff. Yes, I think that was it.
Yeah, there's no, I remember they're not.
You have to memorize the Babylonian symbols, the Mayan symbols, yes. So look at part C. Can anybody tell me how many places there are? Totally 3, because the blueberries would be next to each other if they were in one place. 3 places. What are the place values for Mayan?
160 and 3600.
You think of Babylonian. Don't be thinking no Babylonian when you talk about Mayan. 120, 360. And of course, how many of each do I have? What does a blueberry mean? 1. It's got 1, 120, and 1, 360. So then you just add those up, yes? So Mayans almost have a base 20 system. Why did they deviate? Huh? Yes, because they want the length of the year represented in their number system, yes. Okay. What about part D? How many places are there? There looks to be 3. And Babylonians, hit me with it. There.
Oh, 160 and 3600.
And what does this little Pac-Man symbol mean? 10. So it'll be 3600 plus 4060s plus 6. And then whatever the hell that is. What would that be, Jeff? 9,006? I could have done that wrong in my head. Let me think. 6,006, that sounds better. Yeah. Okay. I'm not surprised. My head didn't do it right. Is everybody with me on that? It's okay? Okay. What about part E and F? Now F is a good example of the book being silly. They use E for 11 and T for 10. That's really stupid. Right, we're going to use A, B, C, S. You with me? So look at part E. How do I tell how big each place is? Space 2, yes. So how big are the places? Yeah, this is 1, 2, 4s, 8s, 16. You just keep multiplying by 2, right? So now you just need 16 plus 4 plus 1. Yes? You gotta love this shit. So it's trippy to think about our number system being different than based on 10. That's trippy. It'll mess with your mind. But the math involved is very minimal. It's very low level math. You know, like whatever you say, Jeff. Okay. And then finally, this guy. So this would be 21, yes. What about this guy? E.T. E.T. Thank you for laughing at that. So it's base 12, so this is 1s, 12s. And now if I write it 11 12s and 10 1s, now I just have to multiply and add, right? Hold on. Okay. Broadcast. Hello. Hello. Okay. All right. Sorry. So it'd be what? What the hell's that? I don't know. 142. Is that right? Go, Jeff. You know your job. It's amazing. Where? Is that okay? You guys good? Obviously, on the test, I'm not going to reference you to a problem in the book. Yes. I just was lazy on that one. Oh. Where to the layers? Oh, yeah. I like this problem. Of course I would. Oh, yeah. This is great. Okay. So, surface level of this problem. I kind of hope you guys realize the answer. The problem should be, how do I show this guy? Right? What is the answer? Does somebody just know the answer and you're not sure how to show it? What's the answer? Number 17. Oh, okay, all right. What does it mean for A to be 20% less than B? What would you take 20% of? If A is 20% less than B, what do you take 20% of? B. If B is 20% more than A, what am I taking 20% of? I need you to see this. Which one's bigger? B is bigger. So 20% of B is more than 20% of A. You guys see that? Okay, so 20% does not equal 20%. Bless you. Damn it. Okay. No, not quite. Hold on. All right. So, on the surface, I know. Well, let's see if you agree with me. I'm gonna stop. 20% of B is more than 20% of A. Yes? So if I take 20% of B and subtract it from B, that is more than taking 20% of A and adding it to A. It'll never get back. So here's one way you can do this. Pick a number for B. Pick a nice round number. So can somebody give me a beautifully round number for B? 10. Kick ass. Look at that shit right there. Okay. So if B is 10, how do you figure out what A is? So 20% of 10 is, no, 20% of 10 is 2. Subtracting from 10, you get 8. Okay. So that would mean, oh man, how am I gonna make it? Who knows? Hold it. I re-upped my Dayquil. Not NyQuil. NyQuil would be bad. Dayquil I did. Okay. All right. So are you with me? Why can I just pick a number? Because if this is true, it's always true. So I just pick something. If B is 10, A is 8. How do I get 20% more than A? Now, I think the fluoride in the water is going, sorry, I'm going to do my RFK Jr. impersonation. How do I get 20% more than A? How did we get 20% less than B? We took 20% of 10, subtracted. How do we get 20% more than A? 20% of A and add it. What is 20% of A? How do I do 20% of something? Hell no, what does of mean? Multiply. So do 0.2 times 8. You'll get 1.6, yes? Add it to 8. What do you get? 9.6. I really need you to understand. Here's a good example. If the school cut my pay by 20% out of nowhere, and I'm like, what the shit? So I go to complain. Let's pretend like I was making $10 an hour. Thankfully not. Hold on. If I was making $10 an hour, they cut my pay by 20%, now I'm at 8. They go, oh, we're sorry. We'll increase your pay by 20%. I don't get back up to 10 because the second 20% is of a smaller amount. It can never get back up. That's basically what this problem is saying. Okay. I'm really sorry about this, by the way. I don't know what to do about it. So, the immediate answer is no, but then you can pick numbers to show me why. Okay. Can somebody tell me there is one number this works for? What if B is 0? And A is 0. Because what's 20% less than 0? 0. So a lot of the time 0 is the answer. We very often call it the trivial solution. It's like, well, yeah, if you make everything 0, whoop-de-doo. Okay. So that one was a little bit tricky. I agree. Hopefully that made sense. Throw my coffee. Okay. Man, I thought I was having coffee. Yes? Maybe. Let's see. Oh, okay. Hello. Okay. So what is that physically telling you to do? Put down 5 reds and take away 6 reds. You with me? So you would draw a picture and you could put, like, for me what I did is, since I don't have colored pencils, I just did 1, 2, 3, 4, 5. Looks like a 4-eyed unimpressed circle. Whatever. Okay. How am I going to take away 6 negatives? I only have 5 negatives in there. You all know how to do this. Add a 0. Kick ass. And what do you mean add a 0? What does that mean? A positive and negative. So now can I take away 6 negatives? What am I left with? What am I left with? Yes. And of course we all know, what is -5 minus -6? It's -5 plus 6, which is 1. Sweet. The nice thing with those problems is you should be able to check your work pretty easy. You just do the problem, right? Okay. Is that okay? That's pretty much, or if you got color pens or pencils, you could do a little red and do little black circles. Yes. Okay. Wait. Sorry. Okay. Yes.
Did you go over number 1? Did you go over number 1?
1? I don't know. Let's see. No. By the way, I wore this shirt specifically for you. I just got it. It's my new favorite shirt. Do you get it? Do you get my shirt? Okay, good. You should get my shirt. Okay. Because every even number is 2n. 2n minus 1 would be n. Odd number, so I literally can't even. So it's, I love the shit out of this shirt. Okay. So, show that every odd number can be expressed as the sum of two consecutive counting numbers. What does every even number look like? 2n. So what does every odd number look like? Minus 1 or plus 1, it doesn't matter. So we'll do minus 1 because I got my shirt going on. Now, let me do it this way, since we chose this. Somebody give me a counting number. Sorry. 17. What's the number before that? How did you get there? Good. So somebody give me every counting number. N. Yes? What's the number before that? Yeah, so if I have n, what comes before it? N minus 1. And what do you get when you add those together? 2n minus 1. Yeah. Kabam. So that is a use a variable situation, if you ever saw one. Every odd number, you're like, what the shit? I don't have that much space, Jeff. But you just represent it with variables. That's how you get every odd number. You guys kind of with me? No? I'm pretty sure right now, you guys are all like, what the shit is the actual question this guy's going to ask us? I don't know. We'll find out. Yes? Which one? $21. Oh yeah.
Well, I'm just kidding, 22, because there's two numbers.
22? Oh yeah. Yeah, I'm just showing off my command of the number system. Okay. So, I mean, what is that symbol asking us? Of course.
It's just an exponent of negatives.
Huh? What's happening? What does that symbol ask us? Okay. What is that symbol? Square root. What's it asking us? And you're all like, Jeff, it's a bunch of ink on a piece of paper. It's not saying a damn thing, man. Yes?
Is it asking you to like, is the square root the exponent of 1/2 or?
Sure, but you don't have to get that deep. It's just saying, what does it take 2 of to multiply the 81? That's all it says. And what does it take 2 of to multiply the 81? 9. And it's understood to be a positive answer. Yes? Or you can think of it as what squared is 81? So to do this problem, who remembers how to do this problem? You can guess at it. Yeah, if you guess 5, how do you double check? 5 times 5 times 5. This says, what does it take 3 of to multiply to 125? Yes? Okay. Now what about, is that okay? What about part C? It says, what does it take 2 of to multiply to negative 16? What's negative 4 times negative 4? So the answer can't be negative 4. What's 4 times 4? 16. So the answer can't be 4. So what's the answer?
Plus or minus.
Say again.
Plus or minus.
No. That symbol means what number do I multiply by itself to get negative 16? There's no real answer. No real number will do that. I can't take the square root of a negative 16. Not with real numbers. Do you guys all get that? I can't do the square root of negative 16, because if I take any number times itself, it will come out positive or 0, yes? Negative times negative is positive, positive is positive is positive, so. Entire civilizations thought that didn't exist, but it very much exists. We're just not going to get into it. I can't remember if I showed you that video. Okay. It's not gonna work. It's not gonna work. I like what's going on. You guys are all very busy. This is cool. Just let me know if you need some help. I'm gonna just stand here and stare at you. Yes.
So since we worked on ratios before, there's one like that, like 14.
Oh yeah. Okay. Oh, there's the cookies. Miss Keebler. What do you guys think? Is that cool? So, guys, did anyone try number 14 out?
Yes.
Do you think you got the answer? I really, this thing. Okay. You want to share with us how you got it?
I split 45 into fifths first.
You split, say again? Oh, you split 45 into fifths. I like it.
To get
Good. So 1/5 of 45 is 9.
and then multiply that by 3, which equals 27.
So 3/5 of 45 is 27. Okay, let me catch this. So I like this. She said, okay, 3/5. So if I knew what 1/5 was, then 3/5 is easy to get. 3 times 9 is 27. Okay.
Which is 3/5 of the class. And then I basically did what a double batch would be. So 3/5 plus 3/5 equals 6/5,
Sure.
which equals 1 and 1/5, which means that 1/5 of the class will get more than 1 cookie or 9 students.
Oh. Okay, so then double 3/5 is 6/5, which is 1 and 1/5, which is a whole class plus a 5th of the class. And you already know a 5th of the class is 9. Okay, good. So, is that the only way to do this problem? Hell no. Okay. But that's neat. So I wanted to know if somebody tried it, how'd you do it? There's many different ways to do this problem. And that, I kind of did that on the answer key. Yeah. Do it again.
I just multiplied with 27 by 2. Since
Yeah, okay, good. 27 times 2 is 2 batches. That's 54 minus 45 is the extra 9. Kick-ass.
That's what I did too.
I love it. Mathematically, it's the same thing you did, but you were just using the fractions and you guys are using the whole numbers. Okay. Yes, sir.
you already showed it, but can you do it over number 20? I didn't get.
Number what now? Sorry.
20.
20. Okay. Negative 5 is there, yes?
Okay.
And the problem is asking me to take away 6 negatives. I only have 5 negatives. So of course I'm gonna give myself,
Okay.
yeah, and then I can take away 6 negatives, yes, okay. I like it. So this is the kind of problem that would probably be at a desk with the manipulatives, yes? That's gonna be very exciting. Probably gonna have like 2 or 3 stations. I haven't figured it out yet. Probably 2 or else I'm gonna go crazy. Running between all of them. Yeah. We'll see. You did great. Yeah, flip this side. I like it. Yeah, so when you divide and multiply by negative, you flip this side. Cool. Oh man, so many registers are lost. It's gone. Cool. It's gone. That's so neat. Okay. Page 7. Now serving at window number 11. Fix it. $19. So which number is in the hundreds place? Yeah. This is in the tens place. This is the hundreds place. So, am I going to round to 199 or am I going to round to 200? Because the next number is what? What's the next number over? Find the place I'm interested in. What's the next number over? 8. So am I going to round up to 200, 2.00, or I'm going to stay at 1.99? The next number is an 8, which is more than 5, yes? So this is the one that trips people up. Do you guys see what I mean by I'm either going to leave it at 199 or I'm going to take it to 200, 2.00. Since it's an 8, of course I'm going to shift it up. So it's going to go up to 2.00. That's the one that people kind of lose touch with rounding. It's just the next number up, that's all. The next number up from 199 is 200. So, yeah. If it was 199.2 before, I would have left it at 1.99. Yeah. Okay. Yes?
For number 13, do you just do the number and you start at 6, 7, and then you just go back to?
Yeah, so you gotta break up your stuff into 7 pieces. Go to 6 sevens and go back to, yeah. Before I burnt, that's good. Yes?
Number 8.
8? There's only one number 8. We just went over number 8. Didn't we? This 8, yes? Okay, I don't know if you weren't here earlier, but real quick. What's the rule for 6? How do I know something's divisible by 6? If it's divisible by 2, And 3, yes. Why does that work? Because 2 and 3 are relatively prime. So what's the rule for 14? If it's divisible by 2 and 7. What does even mean? It's divisible by 2 and it's divisible by 7. Since those are relatively prime, it must be divisible by 14. So yes, it's true. If I said 2 is an even number and 8 goes into it, does 16 go into it? No, not necessarily, because 2 and 8 are not relatively prime. Say again? Sure. 8 to number 16. Okay. This one down here. Okay. So, what's a whole number? What's a whole number? Are these whole numbers? No. These are integers. So, what's a negative power mean? What's a negative power mean? 4-letter word starts with F, you can say in mixed company. What's a negative power mean? It means flip. You with me? So 2 to the negative 3 is actually 1 over 2 to the third. So you've rewritten it with a whole number. Okay. So 1 over 2 to the third times 1 over 4 to the third is 1 over what to the third? 1 over 2 to the third times 1 over 4 to the third is 1 over, you're multiplying. It's 1 over 8 to the third. Yeah? Okay. And then part B is just add the powers, right? Yeah, this one's kind of silly because we kind of already talked about the fact that this property holds, but it's just kind of like stepping you through. The property still holds even if it's, oh, Calissa, did you get a answer key? That would help out. You're welcome. Let's get out of here. Okay. Is that all right? Is that better? So, these both end up being the same in the end. Because this would be 2 times 4 to the negative 3. 8 to the negative 3, which is 1 over 8 cubed. It's the same thing you get in part A. So you're just showing that they end up being the same thing. So that means the property holds even if they're negative powers. Okay, maybe. Yes.
Can we do number 9? Which
Yes.
is subtraction from
Oh, we did this already. So you subtract 300, then you always subtract the smaller one from the bigger one. And then right here you can see the answer. Because 60 goes into 240. Yeah? Yes?
I think I'm just confused on when to stop.
Oh. In general, you stop when you can see the answer. So, real quick, what is the greatest common factor of 3 and 6? Which means, what's the biggest number that goes into both?
3.
Of course it's 3. What about 10 and 20? 10, of course it's 10. What about 60 and 240? Same thing. Why was it 10? Because 10 goes into 20. Why was it 3? Because 3 goes into 6. What about 60 and 240? Does 60 go into 240? Yes, so that's the GCF. The biggest number that goes into both. Does 60 go into 60? Yes, does 60 go into 240? That's the biggest number that goes into both. Now, watch. You could keep going. Minus 60 is 180 and 60. Minus 60 is 120 and 60. Minus 60 is 60 and 60. What's the GCF of 60 and 60? Freaking 60, yeah. So you could keep going if you needed to, but you stop when you can see the answer. Yeah. At the beginning, I couldn't see the answer because they're freaky numbers. Yeah. By the way, somebody just left. If you're gonna leave early, which is fine, you probably want to grab a answer key before you do that. Yeah. Maybe I'll just give these out. Let me just give these out. Yeah. You want one there? I thought you were gonna come over. Which one? Sorry. Oh, probably not. No, in fact, this is not just 22 questions long, right? It's just A, B, C, D. See you. I'm excited about the final because I get to see so many people I haven't seen in so long. It's gonna be neat. It's gonna be like my class. Oh yeah. Say again. Oh yes. You're Johnson. There you are. Wait a second.
What should I
See,
type?
using Polish. It's always a good thing. More stuff than you are. Yes. Yeah, if you got something back, if you got, oh boy. Oh boy. If you got something back from me and it doesn't say anything, it's assumed good. Huh? What? Oh, you guys, okay. I think my hearing's going too. This is awesome. It's up to you if you want more practice for the final. I mean, a single homework assignment, it's not going to do a damn thing. So it didn't really matter that much.
Because I just didn't know if you wanted me to correct it, redo it, because I knew there was nothing written on it.
Oh, so you're good. You just do it for your own edification if you want to. Yeah. By the way, I can't remember if I said this to you guys, but I don't say this too early in the semester, but I never let homework fail a student. So if you get a passing grade, and then I put the homework grade in, and it suddenly goes to below 70, you pass. Right? Don't let homework fail you. Because it's already hurting you, so I'm not going to let it hurt you twice. See you guys. Yes? A2 number 24. Oh yeah, okay. So, real quick. You know that these two numbers have to multiply with this. Yes? They can't both be 12. Even though 12 times 12 is 144, yes? Because these two numbers have to multiply with this. So a really smart way to do this is these numbers. These two make this, these two make this. they have to be factors of 144, right? So, is there a factor of 144 that has 4 as a factor? And is the other factor 144 have 9 as a factor? So start with, how do you factor 144? 12 times 12. Well, we already said that can't work. What's another way to factor 144? So here's a cool way to do it. Let's see. Arg, where are you? You're gone. There you are. 144 is 12 times 12. But 12 is 4 times 3, yes? So you get 36 times 4. You see that? 36 times 4. Yes? So if I put a 4 here and a 36 here, that still won't work because I'd have to put a 1 here, yes? Okay, you see how to try to get more numbers that you might be able to put here? Okay, so then you start to think, okay, what about, is this 18 times 2 times 4? Is this 18 times 8? If I put an 18 here and an 8 here, negative 9 times what is 18?
2. Or -2.
Negative 2. Negative 2 times negative 4 is. So it's really just about getting enough things to try. And keeping in mind that whatever you put here has to have 4 as a factor. Yes? And vice versa for the 9. Yes? Okay, and then you keep going. Same idea. Yeah. Yeah.
So 9.2 is a part of the final, but the homework is extra credit, right?
No, 9.1 is special credit. 9.2 is due.
Oh,
Yes.
okay. From 9.1 is on the final still, right?
9.1 could be a bonus question, but, and again, 9.1 is just fractions, but the fact that they could be negative, which is kind of silly.
Right.
Yes.
So for 15C on the practice file, is there like a quicker way to do this?
Well, okay. When I see a problem like that, what's the biggest number that goes into both the bottoms? See, what's the biggest number that goes into 15 and 50? What's the biggest number that goes into 15 and 50? 5. Okay, so write both bottoms broken up as 5 times something. You with me? Now you can see, what is this first guy missing that the second guy has? And then you give it to him. What's the second guy missing that the first guy has? And then you give it to him. Because LCD is all about building up the bottom so they become the same. So if you know what they already have, you can see what they're each missing.
Could you use some of the manipulatives to?
Do it again.
Because I need help with the base numbers, you know, you said you might have us do those.
Sure.
The blocks, can you
Yeah.
use those right now?
Huh?
Can you use those right now?
Sure. Come over. Where is it at? I think it's the first
I
one.
struggled with the base.
So there's base 3, base 4. Yeah, go for it. It's down there. Mm-hmm. Yeah, that's, no, this would be 201. What you need is, these guys. You're missing this piece. Yeah. So there's your 21. See, this would be, 201 if you had two of these. Because this is basically like 200. Yeah. Three base 4. Yeah. Mm-hmm. Yeah. And what's, so what's that? Yes, good, that's it. See you.
So, I'm just watching what she was doing.
Oh.
It's just the two steps, right?
What do you
For
mean?
the answer.
There are 3 at the end because you have 2 and 1. You add 3,
Oh, that's what I was missing.
so then you get 3 longs.
That's what I was
Yeah.
missing.
Sure. Ah. I think I can turn this off.
Are you doing okay? Are you doing okay?
Not the best.
I appreciate you being here.